Hydraulic power. This is similar to just power, rate of work. However, when you in a hydraulic system, we have seen that rate of work, power in F force times velocity, like that, or in terms of torque, we can do basically torques time revolution per minute. We can also use that relationship to measure power. Equivalent, and not exactly Tn, but close. But in a liquid system, in a fluid power system, we have, instead of force and velocity, we have more availability of pressure and flow rate. So we want to express that in terms of pressure and flow rate. Now, if you look at this relationship FV, we can simply write P AV. So basically, force is pressure times area, and then we can keep just P, and area times velocity is the flow rate. Now, so this typically P is in PSI, and then Q is in gallon per minute. Gallon per minute. Now, if we want to see this relationship in horsepower mode, let's convert this into horsepower. So the power, hydraulic power, we found the relationship. P typically it's in PSI in a fluid power system, and Q is in gallon per minute. So if we want to convert this into our horsepower, we have to first go to pound per square feet. So pound per, this is in PSI, inches square, and this is in gallon per minute. So we can convert that. We can keep the pound, that's okay. Inches square, we can convert that to 1 foot is 12 inches. So 12 inches, and then we can whole square that to cancel that inches square will have only foot. And then Q, 1 gallon is actually 1 feet cube. I want to keep it in feet cube. 1 feet cube box can hold 4.78 gallon of liquid. And then we have minute, so we can say 1 minute is we can cancel minutes, so we can do 60 second is 1 minute. So this 1 minute cancel, gallon cancel, so I'll have feet cube per second. Here I have PSF. So if we do, so this will be P as 144, bring all the constant in the front, 144, and then this will be actually multiplied with this 60, so that will be 7.48 times 60 is 449. So here 449, and then I have P is in PSF square, and then Q is in feet cube per second, like that. So if we do, let's see, times 144, so we got, I'm gonna go here, equal to, if we do this 144 by 1449, then it will be basically like this, 1 by 3.1167. and then you can see here feet is square, feet cube cancel out, feet is square cancel out, so I will have pound feet per second, pound, so P and Q, I have pound feet per second. So as you know that 1 horsepower, if I want to convert that to horsepower, then 550 pound feet per second is 1 horsepower. So pound feet per second, pound feet per second cancel out. So what I have here, basically, if we multiply 550 and this, so I have P. Now remember, P was in PSI and Q was in gallon per minute, and this conversion becomes now 1714, and this will be in horsepower. So the hydraulic power, if you have pressure available in PSI and flow available in gallon per minute, and then you divide by 1714 to get the horsepower.